So how do we go about doing this solubility lab when we haven't even done it? Well, I would encourage you to work on reading the solubility lab that's in the lab manual. I think it's the alternate lab 1. So reading through and watching the video that explains how the data is taken, even though you aren't going to take the data, understanding how they go about collecting the crystallization temperatures and making the solutions will help you make sense of some of this analysis. So notice this is an example. I've changed the solute that we're using, and I'm going to change the data. It's a much simpler form, but you can use this, what we're talking about, on the data set you're given and the tasks you're given to compare. So I first want to look over at the data set. This is going to ask me to find the average crystallization temperature, the standard deviation of the temperature, and the solubility. This is no longer KCl, it would be NaNO3. Let's look over at the data set that I created for this example. So you have a similar data set. So you have what the solution was made up of, how many grams of, actually it wouldn't be KCl, it would be NaNO3, and how many milliliters of water. So I made a solution by taking 12.103 grams of sodium nitrate, and I added 18.25 milliliters of water, and I made a solution. I heated it up. I let it cool down and measured the crystallization temperature 5 times. So I want to get an average crystallization temperature and the standard deviation of it, and I also want to get the standard solubility of this. Let's talk about the standard solubility first. Okay, so I'm going to move over here to this side. Standard solubility is defined as the grams of solute per 100 milliliters, 100 grams of water. Note that we have volume, right? We have milliliters of water. So I need to first convert that to grams, although it turns out to be pretty easy. The conversion between volume and mass is the density. So I go look up the density of water, and it turns out that it's 1.0 grams per milliliter. So I'm going to take 18.25 milliliters and multiply it by 1, and I get 18.25. So I don't really have to do any conversions, right? When we look over here, we recognize that this volume of water, since water at these temperatures has a density of 1, is really the same, it's really the same number of grams. You could make an argument that technically, as we're using these higher temperatures, slightly different density, and make corrections for it, but we're not going to do that. So the next thing is that in this case, if I look over here, I have 12.103 grams of NaNO3 and 18.25 grams of water. So 12.103. So I have 12.103 grams of NaNO3 in 18.25 grams of water. But standard solubility is I have to re-ratio this to be how many grams of solute would be in 100 grams of water. So I need to do a proportion, right? I have my, on the top of the fraction, I have the sodium nitrate mass, and on the bottom I have the water mass, and I want it per 100 grams. So this is really just like a ratio, right? Let's put this little underline so it looks more like a ratio. So I can just solve for the x, this is up here, by multiplying both sides by 100 grams, right? And in this case, these will cancel out. So over here, so if I do this, this is going to be the mass of the solute divided by the mass of the water times the 100. And this is going to be the same for each one. So I can actually do this as a calculation. I'm going to add a couple of lines here so I can do my solubility. You could do the same thing right in your spreadsheet. Okay, so I said that it's the mass of the solute. Note that I can just click on the cell, divided by the mass of the water, but it turns out to be the same as the volume of the water. And then I need to multiply by 100. So it calculates it for me. So it's 66.3 in standard solubility grams. This is now going to be grams per 100 grams water. And this solution is going to be the same thing. I can either retype it in, or I can just pull over. It turns out if I pull over, right, if I use my Excel tricks and I copy this over, it's going to figure out. So C4 divided by C5, so it just re-references it over. Or I could have retyped it in. Okay, so 66.3 and 48.9. All right, now I need to come up with the average temperature and the standard deviation temperature. Well, the average is just the average of these numbers. Once again, we're working in Excel, so let's just do equals average. So I happen to know that that's the the function, but if not, you could have looked it up. Also, it turns out up here, this has a bunch of features that you typically use for a column: sum, average, counts, max, min. So I could have picked average here, and it even self-selects. It says, oh, I bet you want all the numbers in the column. Or I could do equal average, parentheses, and I could have selected the first one and held it down and dragged to the bottom one, and I get that one. So I now have an average temperature for each one as well. So 46.0 and 28.9. 46.0, 28.9. Note that Excel is going to say, oh, well, it doesn't matter, it's just a 0. If you want the 0 to show, and this is going to be talking to your instructor whether they prefer it for sig fig reasons, I can use these increase decimal and decrease decimal buttons. So I can increase the decimal, that's too many, I decrease it 1, and I can make it display. To get the standard deviation is now going through, so how far do these vary on average from this? If you remember the formula from 123, I first would have to take the difference of each item from 46. So 46 minus 43, square it, plus 46 minus 46.8, square it, plus 46 minus 45, etc. And then I divide it by one fewer than the number of items, so divide by 4, and then I take the square root. However, if I look, there's a variety of standard deviations. I want the standard deviation of the sample. And I could have looked up the details on that. And it would be good to actually check to see if it's the same thing. Equals this minus this squared plus this minus this squared plus this minus this. Whoops, I forgot the parentheses. Oh. Let's see. So I had to come up here to be able to keep going. Squared plus this minus this squared plus this, whoops, again, parentheses, this minus this squared. I want this all added up. So all of this added up in a total set of parentheses, divide by 4 because there's 5 items and I want to use one fewer, and then I need the square root. Well, it turns out I can do SQRT is square root, and this would all have to be enclosed. So I could do it the long way, I could do it the short way. And since I've done it for here, I'm just going to copy it over. So for the first one, it's 0.6. So I have a much bigger standard deviation here than I do here. And look, I can see that this makes sense. This is 46 as an average, and the lowest one is 45, and the highest one is 46.8. So that's like almost 0.8 higher and almost 1 degree lower. When I look here, I see that this is a 28.9, and the lowest value is 28.4 and the highest is 29.3. So these are much closer spaced together than these. So I expect to see a different standard deviation. All right, so I'm just going to say 0.67 and 0.35. 0.67, 0.35. So I get a sense of how good each set of data is. In their case, you're going to have 12 different solutions, 6 for potassium chloride and 6 for potassium nitrate. So you can see that not all the data is the same. All right, the next task is to attach a graph of the solubility versus average temperature and versus individual temperature readings. So this is a little confusing. I need a graph that's going to have temperature on the x-axis. But I have two kinds of temperature, average temperature and individual temperature. But I can only have one x-axis when I do graphing. It can let me have lots of y-axes, but only one x-axis. So I'm going to have to put all of the individual temperatures and the average temperatures on the x-axis, but even though the solubility will be the same, I'm going to use different columns. One for the standards for the individual solubilities and one for the average solubilities. It's going to look a little funny. So I take my data set. Here's all my temperatures. And I kind of, I'll do it here on the same screen. So I'm going to take these and I'm going to put them down here. So here's are going to be my temperatures. Did I put 46? Did I put the average? This one's the average. No, I really want to do this paste special and just paste the values, because remember this was calculated. It turns out because I have it in the same order it would work, but I'm going to leave that alone. I could also do them at the end. You know what? I'm going to switch. I changed my mind. Now I'm going to put the other, these are all the individual ones. Remember, I want the individual ones. Now, what is the solubility of this one? Solubility. I can't type. Remember, for all of these, it's the same value, 66.3. 66.3. Now, since that's the same, again, I can just drag, it's all 5 of these values have the same one. And this one is 48.9. 48.9. And it's also the same for all of these. And now for the average temp, let's say average solubility. The solubility is the same, 66.3 and 48.9. But the temperatures are now 46 and 28.9. So notice it's really the temperature is the part that's different, but in order to get it to show up in a different color on the graph, I'm going to make a new column for the solubility. And this is what I can now put. Now, if I wanted to put both sodium nitrate and another set of solubility data on the same one, I could make, maybe KCl solubility and average KCl solubility, and I'd have to put all of the temperatures, the individual temperatures for KCl, and then all of their solubilities would go here, and then, not here, they would go over here in this column, and then for the average it would be over here, and I put them here. But I'm just going to make one graph. So delete that. I know I'm going a little fast on the Excel, but it's on a video. You can slow down the speed, you can rewind, so we're okay. So this is what I want to graph. Now hopefully if we're going to do our graphs in Excel, you need to use the XY scatter. It's got to be the XY scatter. Anything else is not going to work. And look at how nice this is. So here I see my individual, all these little blue ones are the individual temperatures, and the red one is the average one, and it even kind of shows me solubility and the average solubility. It's really not the average solubility, it's the average temperature, but I can kind of see my data, and sure enough, this one has a much higher standard deviation. Look at the spread of these dots, individual temperature readings versus this one. I can visibly see it. Now I want to clean this up and put some titles on. I want to show the grid lines. I want to show the little minor ones so I can get a little resolution on it. I need to put a trend line. Now I'm going to use the trend line for the average because I consider that to be the better data. And I have my stuff. And it looks pretty linear. I mean, it's got to be linear. It's only 2 points. Now, in your particular case, you may want to do, if you click on this, if I wanted to do a trend line, if I click on this, note that it would tell me I could do a linear, I could do an exponential, more options. I can do, like, so sometimes for the curves, the polynomial and the exponential can provide better data. So you just kind of play with it till you like the fit. And very likely for at least one of your solutes, it's much more curved than it is linear. So you won't want to use the linear one if it's definitely a curved pattern. Also, I may want to kind of extend this past so I can kind of see what's going on. I happen to know what's coming up, so I'm going to do a couple things. I'm going to change this axis and make it go from 0 to 100. Note that if I click on this, oh, it's still on my, so if I'm on the graphing part of the axis options, I can make this go up to 100. And I can probably do 2 degrees, although if I wanted to get closer spaced line, I could do 1 degrees. I'm going to show you a couple other tricks. So I didn't put my axis title in. So on my Y is the solubility. I'm sure I misspelled it. Yeah, I missed a letter. That's all right. Temperature. And I should put the degrees Celsius as well. Also, if I want to make predictions about what's going on here and here, I really can't do it with this. This line doesn't go far enough. Down here, I can do a couple things. First of all, this forecast will make the extend more or less. And it's usually in terms of whatever your x-axis is. So I want to go maybe like another 20 or 30 degrees in either direction. So I'm going to make this forward 30 and backward 30. So I can really kind of see what's going on. And now, okay, now I can really predict what's going on at different temperatures and different solubilities. Also, if I'm going to have to make some readings off of here, these grid lines are pretty light. If I look here, I can kind of click on this to get all the other things to change about the graph. And I'm going to look at these major and minor grid lines. And if I put it on the paint thing, I can change the color to be a little bit darker. Let's make it like down here, that dark one. Yeah, that looks much better. Maybe even one darker, and I'll make the minor ones that way. So those are the major. I'll do this major, the darkest one, the last one on the list. And then for the minor, I'm going to make it maybe this middle one. Yeah, that looks okay. So now I actually can see if I need to see things. Also, I may want it bigger, right? I can just grab and make this bigger so I can really see what's going on. That's a whole lot better. So I can really kind of tell what's going on with the temperature and the solubility and spine things on the graph. I might want to make this solubility. Again, this is the picture, this is the colors, but I want on the graphing feature, on the axis options, I want the minor axis to be at least 2, maybe even smaller. So I want a tighter grid. I will tell you at this point, I would probably just switch and say I'm going to go to Logger Pro. I'll kind of do that in a little bit, but I just kind of want to show you some features of this. So now that I have this here, I'm going to select this all. I selected the upper left, and then I hold the shift key down and select the bottom right, and I can copy it. And I'm going to go over to, I have an open blank window of Logger Pro, and I'm just going to copy it over. And notice that I probably have to label it. This is, oh, I included the temperature. Done. This is the solubility. And this is the average sol. I'll put average here. I'm going to delete this first one. I can cut that out, so because I accidentally copied that over. And I'm going to head over to this graph. If you've watched the other one, note that, remember, this is showing me just the individual ones. And you know what? I kind of want these to be darker. So for I want these to be full circles, filled circles, and I'm going to make them small, but filled circles, so I really can see them. That's a whole lot better. And then here, it's got filled squares. I might like the diamonds. And they're medium. That's okay. All right, but they're not showing on here. That's because if I have to click on this and hit more, and I can say I want to show both the solubility and the average solubility. And maybe I want to make this a little smaller so I can see. I need to put a trend line on here, so I'm going to do Analyze, Linear Fit. I'm going to use the average for the linear fit, and I'm going to pull these out of the way since there's no data points. And so I can see this well. I can use this Analyze, Examine, and Interpolate feature to really now be able to find points on this line. And so I don't have to worry about having really tight grids, because this up here is telling me exactly what the temperature and the solubility is. All right, let's go back to our spreadsheet and look at what else is being asked. So here I've made the graph. Your instructor will tell you if they want this in a separate file, or if it can be in this file, or whether they want it to be on this particular tab that says graphs. That will be up to your instructor. I guess I should put a solubility graph for NaNO3. Okay, so I have my graph. Note that if you have, in your real lab, you're going to have KCl and KNO3, it would be best if you put them all in the same graph. If you make two graphs, they have to have the identical scales. So you need to have the identical scales so you can make direct comparisons on them. All right, let's go back over here. So I did this. I attached the graph of solubility. If you did a Logger Pro graph, you would save the file and submit the Logger Pro graph as a separate file for your graph. All right, now it says to look up the literature values for the solubilities of these substances, you're going to need to use our library website to access this CRC Handbook of Physics. So I'm going to copy and paste this. I selected it and copied it, and I'm going to go over Note that you're going to have to log in. And it tells you exactly what the status of that, how to figure out your password. And I'm going to look in NaNO3 solubility. Turns out all the solubilities are in the same search. They're all in this big, large table, this aqueous solubility. So this has all these different ones. Notice that it's alphabetical by chemical formula. So I'm in the A's. To be in the N's, I'm going to kind of go along. I'm at K, maybe 13, Mn, Na. Okay, so now I'm in my sodium, but I'm at the W's. So I probably have to go back one page and go to the bottom to find my sodium nitrate. And DNO3. I might have picked one that doesn't have one. Oh, here it is, sodium nitrate. It was just at the very beginning. Okay, so notice if I check on this, it'll highlight it, which just makes life a little easier. I need to find the, at 40 degrees, if I go back to the assignment, it said, what is the solubility at 40 degrees? So if I scroll down to the bottom here, where I have this little scroll bar, and I want to go to where it's going to be like 40, and I kind of have to keep going up and down until I find, so 25, 30, okay, here's 40. So I go down, and because I've highlighted it, it makes it easier to see. So it's 51, but I got to be careful. This is in mass percent, so we're going to have to do a conversion. But let me go back over to my spreadsheet, and it is 51. Okay, I need to know what is that in terms of solubility, in terms of grams per 100 grams of water. So I've kind of written this over here. So I have percent mass, which is mass solute per 100 grams of total mass of the solution. So it was 51 grams per 100 grams. So I need to figure out what that is in terms of per 100 grams of water. So I now need to figure out how many grams of water are in this. Well, I know of this 100 grams, this is really 51 grams of solute, and obviously 51 of the 100 grams is coming from that sodium nitrate. So now I'm going to take 100 minus 51, and that's 49 grams of water, right? So this is 49 grams of water and 51 grams, so this is sodium nitrate to water. So I'm kind of converting it over because now I need mass of solute. My solute is sodium nitrate per water. Now this isn't scaled to 100 grams, but now I just have to do a rescaling. So if I multiply both of these by 100, so 100 times 51 over, this is kind of like when we were figuring out our standard solubility. So if I do this, I get, let's see, 100 times 51 divided by 49. I get 104.1. So in terms of solubility, it's 104.1. So now I'm going to go to my graph, and I'm going to look up what is the solubility at 40 degrees. By the way, I totally made up those numbers that I'm using for sodium nitrate, so it's probably going to be way off. That's okay. You get the idea. Yours will not be that way off. Okay, I want to look, what is the solubility on here at 40 degrees? Since I'm using the Logger Pro, I could either look straight on the graph and try to interpolate it, but I'm just going to keep moving this till I get to 40. And I can use the arrow key to really get precisely on 40. And I can get a nice reading without having to really try and strain my eyes. All right, come on. 40. So 60.2. Yeah, we're way off. That's what happens. 60.2. Okay, so I want to get a percent error. Well, hopefully you remember the percent error is the measured minus the known over the known times 100. So this is equal to, what was it? The measure was 60.2 minus 104.1 divided by 104.1 times 100. And if I hit, because I started with equal, if I hit equal, it's going to actually tell me. So it's negative 42%. Usually we ignore the sign and just say it's 42% error. So this is 42% error. Yikes. But again, that's what happens when you make up data. All right, so how would I do this next question? Using your graph, look up the standard solubility of sodium nitrate at 65 degrees. And if you only had 73.5 milliliters of water, how many grams would you dissolve in it at 65 degrees? So I'm going to look up the standard solubility. Again, I'm going to use that graph. So now I want it at 65. So I can get really precise using this interpolate and examine tool in Logger Pro. And I get 85.6. So I go back to my spreadsheet, and this is 85.6. But I have to re-reference it. That's how many grams could be dissolved in 100 grams of water, right? So I have 5.6 per 100 grams, and I want to know how many is that per 73.5 milliliters, but remember for water, that's grams as well. So I need to find the X. So this is going to be, we'll do it like this. So I'm going to do 85 divided by 100, and if I want X, I'm going to multiply both sides by 73.5. So this is 85.6 divided by 100 times 73.5. And I get 62.9. So that's 62.9 grams. And it would make sense, right? If I could fit 85 and 100 and I've got like 3/4 of that, I can get like 3/4 of 85. The last one, now I'm going to have to scale up. I only have one data, but you're going to have to do this 2 times because you're going to actually be given 2 different solutes. Your instructor may or may not give you this question. But on the question in the lab report, it has KCl and KNO3 and it had 2 different, so I've kind of scratched it off. So I'm just going to use 15.8 grams in 43 grams of water. And I need to know what is the minimum temperature I have to heat it to get it to dissolve. Then the hint says convert each solute ratio to standard solubility. Then find the temperature needed for each solute. Then use the higher temperature of the 2. Now we're just going to find the temperature, but you would have to do it 2 times and pick the higher temperature. Okay, so I have 15.8 grams in 43 grams of water. But I want to know how many grams that is in 100 grams of water. So I'm really setting up a proportion and I'm solving it. Here, I'll make them pretty, look like they're actual graphs. Okay, so this is going to be, if I want to know what the standard solubility is, it's going to be 15.8 divided by 43. I multiply both sides by 100 to get rid of it from this side. And I have 15.8 divided by 43 times 100. I get 36.7. So I want to find out at what temperature is there a solubility of 36.7. So I go back to my graph. Now, instead of looking at the temperature, I'm looking at the solubility. I want to move it till it says 36.7. 36, whoops, I went a little. So 16.9. Now, I could have also done that by just trying to find 36.7 along here if I'm using my graph in Excel, and then coming up to the line and then going down and interpolating what that is. So let's see, 16, I think it was 16.9. I could have also used this graph, right? I could have found 36, so this is 20, 22, 24, 26, 28, 30, 32, 34, 36.7. Come over to here, come down and read off what graph this is. But as you can tell, it's much harder to do here. Remember, I might have to actually like make this much bigger and really be able to kind of layer down to really see exactly what and I'm going to have to kind of interpolate between maybe the 16 and the 17 to figure out exactly what this is. I think these are 1 degrees. So you can choose which kind of graph to use. It's a little bit easier to graph in Excel, but the Logger Pro was made for graphing, so you decide what's going to work for you. And that's how I need you to work through the data on this one. So you're going to get a lot of practice with graphing.